Hello everyone, I am making this video to walk you through the first assignment for CrystalMaker. So when you first load the document for your assignment, this is what you should see on the left here. At the top there are instructions for installing the software, so if you don't have CrystalMaker installed, go ahead and do that. And then the next step will be to open the software and then register it. So IU will give you a registration key, you put that in, and then it's yours. Okay, once that's all done, then we're going to go and actually open a mineral. And so the way we do that is, when you open CrystalMaker, this is what you should see. Okay? You'll load in here, and there'll be a bunch of folders, but what we're going to do is follow this file path that I've got highlighted. So we're going to go to Reference, and then Inorganics, just double-clicking to open these, Minerals, Silicates, Orthosilicates, Olivine group, and then Forsterite is what you will be opening. I will be opening a different mineral so that I don't do your homework for you. So I'm going to go up to the search bar here and just type in the first few letters of kyanite. That's another way to quickly get to minerals that you want to navigate to, is just to search for them. So I will be doing kyanite. I already have it open. So when you first load your mineral, this is what you should see. It should look sort of blocky. A couple colors, that sort of thing. And let's have a look at our first task. So the first task is changing the model. And what we want to do is change our model from polyhedral, which is what we're in now. These are a bunch of polyhedrons. And we're going to go to the ball and stick model. And so the way we do that is we go to Model and then Ball and Stick. So up here at the top of the screen, you can click Model, and then Ball and Stick, or use the keyboard command that's listed right there. But we click Ball and Stick, and there we go. So now we can see a bunch of different colored spheres and bonds between them. So check in the top right, look at what your elements are. In my case, oxygens are the red, silicons are the dark blue, aluminum is the light blue. Cool? All right, so an important thing that we're going to be doing in these assignments is capturing what's on the screen, right? We want to all make sure that we're on the same page and that we're looking at the same thing. And so an easy way to do that is to just capture what's on the screen and paste it into the assignment. So the way we do that is you can either go at the top, like we did with Model, go to this top toolbar and go to Edit, not Model this time, but Edit, and then Copy Graphics. And so what that does is just sort of copy what's on the screen. Or instead of going and clicking up here and doing this, you can just use this keyboard command listed right there. For me, it's Control-C, so we'll just click Copy Graphics, boom. And look at this. Our first task is to show the Forsterite crystal displayed using the ball and stick model. Remember, I'm using kyanite, so yours will look slightly different, but the point is the same. So we want to replace this image, and since we went to Edit and Copy Graphics, what that did is put an image of our crystal on our computer's clipboard. So the way you paste what's on your computer's clipboard is just with Control and V. And so you can click on the image and then hold Control, press V, and there we go. Mine's a little wonky since it's standing up and down. So let me sort of show you what I mean. See how mine's tall like a cell phone screen? Let's back up for a minute. So I've just undid what I had done there. So if I maximize my screen to be the full width of my monitor, then I do Control-C. So now I've copied graphics again, and I just use this Control-C command. So copy graphics, and then we can minimize, click on the image again, copy paste, and now it's nice and wide. So I would recommend doing it this way. I had it open sort of tall to keep both of these on the same screen, but you want to do this sort of long ways, like I have now. Okay, so we've done our first assignment. We've taken a photo of Forsterite displayed using the ball and stick model. Great. So now we're going to switch back to the polyhedral model and do it again. So let's go back to CrystalMaker. Remember, we go to Model and then Polyhedral, but there's also these keyboard commands. So click on Polyhedral. Those keyboard commands will just instantly snap you to the new model. So if I hold Control and press 1, now I'm back in ball and stick. If I hold Control and press 3, Now I'm back in polyhedral. So once you get used to those, you can do it very quickly. And so our next task was to just take a picture of this in the polyhedral model. So I'm going to do that. I'm going to hold Control and press C. Now I've copied my graphics. I'm going to click on the image, and I'm going to paste. Perfect. Done our first task. Okay, so now what we want to do is get used to manipulating the viewing orientation of our crystal. And if you've been confused about like me zooming in and out or anything like that, watch the video 0, the intro video. That tells you all about how to use the controls. Okay, I do highly recommend it. We'll talk about it a little bit here, but again, I recommend the other video. So anyway, let's change the viewing orientation. We're going to click on the Orient button up near the top, and then we're going to select A, B, and C. Okay? So in CrystalMaker, the Orient button is here. You just click on it, and then remember the instructions said to select A, B, and C under the shortcuts. So A, keep an eye on these vectors down here in the bottom left. So you see we're looking straight down the x-axis. The x-axis is going in and out of our screen. Z is up, Y is to the right. And notice I clicked A, but we're looking down the X. This is the convention. A is X, B is Y, C is Z. So if we do B, now we're looking down the Y-axis. That means Y is coming in and out of our screen. Z is still pointing up. X is kind of pointing down and to the right. Orient again. Press the C button, shortcut. Now Z is going in and out of the screen. Y is down. X is up and to the right. Okay? Okay. So we followed our instructions. We've selected A, B, and C. And then just note that you can also drag this and put it anywhere you want just by using this hand tool down here, the rotate all tool, and you just click and drag and move around, and you can wobble your crystal about. Okay? So task 2, we want to document the structure viewed down the A, B, and C axes. So the first one is forced right viewed along the A crystallographic axis. So let's do it. We go to Orient, we press A, we copy our graphics, Control C, go back to our document, paste. There it is. Now we'll do it again, but viewed down the B. Control C, replace, and one more time. Viewed down the C, Control C, and replace. Awesome. All right, next up, we're going to customize the atom colors. So for this, we want to make sure we're in the ball and stick model, because we want to see all of our atoms, not as polyhedrons, but as spheres. So remember, you can go to model and ball and stick, or just use the keyboard command. But either way, we're going to end up in ball and stick. And then we want to look at the inspector menu in CrystalMaker. Now, we talked about this in detail in the intro video, but we will open up this inspector tab. It's up in the top right. Click on it. And what should default open is the notes. So you can see I'm working with kyanite. It gives a bunch of information, tells you about its chemical formula. Cool. So we are then going to go to well, it doesn't say this in my document, but it'll say it in yours. We're going to go to this next tab, the Atoms Inspector. So one tab over is the Atoms Inspector. And so you can see I've got my aluminums, my oxygens, my silicons. And you can click this little drop down. Sorry, my mouse, when it's got the yellow thing, is a little wonky. You can see I have 2 different kinds of silicons. I have a bunch of different oxygens. And then let's have a look at aluminum. 4 different aluminums. And so what this means for you right now is not terribly important, but just know that we're going to be changing the color of all of these. You could change, like, these are oxygens in the A site. You see it says O and then parentheses A. So I could change all the oxygens in the A site to be one color and all the ones in the B site to be a different color, but we're not going to do that. We're doing just the whole element. right? So all of the silicons, all of the oxygens will be new colors. So just to sort of declutter the screen here, I'm trying to close things down, but again, my mouse is a little wonky with the yellow thing on it. Okay. Awesome. And so if we follow the instructions, we can see that next to the site name, you're able to change the color. So in this color tab, I can make all the oxygens orange or green or whatever. So we want to change the color for you of magnesium, oxygen, and silicon. For me, it's aluminum, oxygen, and silicon. So just change all of the colors. Oxygens were red, now they're green. Aluminums are this light blue. Let's change them to hot pink. Silicon, you're going to be sort of dark red. Cool? So now we have sort of an ugly crystal, but that's okay. It's mine and I like it. And what we're going to do is copy our graphics, take a picture of forsterite in the ball and stick model with the default atom colors changed. So we click back into CrystalMaker, Control C. I've now copied my graphics. I replace the image. Oh, didn't copy it. Didn't copy it. You thought you had me there, CrystalMaker. Edit, copy graphics. Now it should be copied. There it is. Perfect. Beautiful. Okay. So let's talk about some other options for viewing our crystals. So we're going to stay in ball and stick model. And then let's click on the cell button in the ribbon. So this button here, you can see there was a white box that's now gone. I click it again, it comes back. And I call it a box because it is three-dimensional, right? It's not just a square or like a trap or just a shape. It is a boxy three-dimensional thing. Okay, so you should notice that the box switches on and off. So now let's check out some atom labels. So over here, we're still in this inspector menu. And in the second tab, the atoms inspector, you can see there's this column that says label, or, LBL. LBL. So what we can do is toggle the atom names on and off. So it gets a little cluttered, but we're just doing this to demonstrate. So let's use this tool down here, the move tool. So we're going to put the edge in the center of our screen, and I'm just doing this to help declutter the screen as we look at this. Then I just zoomed in. And so we can see that the silicons are this nice red, the oxygens are green, the aluminums are the hot pink. So nice to have labels on there, keep you oriented, but always remember up here in the top right, you can see what colors are corresponding to what part of the crystal. Okay? Okay. Zooming in and out. Again, we talked about this in the intro video. You've seen me doing this here, but this is just sort of a written out version. You can use this tool down here, this magnify tool, to zoom in and out. So if we click, we zoom in. If we hold the shift key on our keyboard and click, we zoom out. You can also, if you have a mouse with a scroll wheel, scroll your scroll wheel back and forth, zooms in and out. And then if you have your hand tool selected, this tool on the far left, and you hold the control key and drag to the right, zooms in, still holding control, still holding the mouse, click, drag to the left, and that zooms out. Okay? In, out, in, out. So you have a few options. Okay, so now we should be sort of up to speed on how to view our crystal in a bunch of different ways. Now we're going to customize the polyhedrons. So that means we have to go back to the polyhedral view. I'm going to turn off the site labels just to declutter things. Work with me, mouse. There we go. So model, polyhedral. And then we want to change the polyhedra. So we're still going to be in the atoms inspector tab. And to change the polyhedron forms, we're going to just click on the little shape that's next to them and then make a selection. Okay, so we can see under the style and label column, aluminum is pink triangle, pink tetrahedrons, and silicons are these sort of dark red tetrahedrons. So if we click on one of those, we see that we can do different things. We could make aluminum these horrible-looking stripes, or a different sort of tetrahedron, or we can make them sort of ghostly and translucent. Okay? I've been saying tetrahedrons there. I got to be careful. The aluminums are not tetrahedrons. Notice they're two pyramids base to base. The silicons are tetrahedrons because they're just one triangular pyramid. So I apologize for my mistake. Okay. And notice on here, we want to leave oxygen's polyhedron as blank. Oxygen is this little red X. That means it's blank. Oxygen is not being displayed. We'll talk about that soon. So just sort of click around, try those different polyhedrons, have some fun with it. But for our next task, we want to change the polyhedrons of both magnesium and silicon to translucent plus atoms and bonds. And so I have it circled here. And what we'll do is we'll click on it, and this is this option, translucent plus atom and bond cylinders. Okay, so click that one. Notice that our aluminums now have atoms on the inside, like a ball and stick model. It has the sphere on the inside with the bonds shooting out to each one of, and notice it goes to each one of the corners of your polyhedron. So what the polyhedron are describing are where the bonds are pointing out to, right? This has 1, 2, 3, 4, 5, 6 bonds. And so what that ends up making is two square-based pyramids base to base. Okay? So that's what those polyhedrons are representing. Little tangent there. We want to also change the silicon to the same model type. Now we can see the silicon atom inside. It's got 1, 2, 3, 4 bonds. And so what it makes is a triangular-based pyramid. Okay? Okay. So now we want to grab an image of the 4-strike crystal displayed using the polyhedral model with magnesium and silicon atom polyhedron customized. And so we have that. A quick way to get to the sort of default view, a nice zoomed out view, is you can click center and scale. And now we're looking just dead at the crystal. We make sure we can see everything. But I'm going to zoom in a little, make sure it sort of fills the whole screen. And then I'm going to copy graphics. Control C, and then click on the image, replace it. There it is. Great. Okay, so we already talked about how oxygen's site label is blank. And the reason that CrystalMaker does this is to just sort of simplify things. And I will demonstrate that here now. So if we click on the oxygen and we want to display it, let's just display it as a sphere. Let's keep it simple. Okay, so now we've just cluttered up our screen a little bit. But again, let's look at something on the edge so we're not looking at a whole bunch of stuff. But look at what we see here. We notice that the oxygens are at each of the corners of the polyhedron. So we were already talking about how the bonds are shooting out to the corners of the polyhedrons. And at those corners are the oxygens, right? So the oxygens are serving as like the framework for our crystal. Everybody's grabbing onto the oxygens and using them to structure the crystal. So let's center and scale and zoom out so you can see that oxygen like follows these nice lines, these nice little patterns that are sort of easy to see as you tilt the crystal around. And so again, those are giving like a framework for our crystal. And they are placed at the corners of each of the polyhedrons. Whoops, sorry, I didn't mean to do that. I wanted to look at a silicon tetrahedron here. So it's the same with the silicon. The oxygens are at each of the corners. And so the reason that CrystalMaker will leave the oxygens as blank is because the polyhedrons are already telling you where the oxygens are, right? If we turn them off now, you as a newly trained mineralogist know that at the corners of each of these tetrahedrons, even if it's not displayed, at the corners are the oxygens. So you can just look at this and say, oh yeah, silicon's touching 4 oxygens because it's a triangular pyramid. It has 1, 2, 3, 4 bonds inside, and each of those bonds, I know as a mineralogist, are pointing to an oxygen. So the polyhedron view is just sort of simplifying things. Again, because we know where those bonds are pointing. They're not pointing like this bond here will never be pointing to like an aluminum. You don't connect silicon and aluminum together, you connect silicon and oxygen, okay? So that is why it is left blank, and I hope that sort of gives you some context. Okay, back to our assignment. Our next task is to display the oxygens using your choice of polyhedron, and then document it. So I'm going to turn my my oxygens back on. I'll make them the horrible stripes, which is just so ugly. Maybe I won't do that. That's horrible. I'm going to do spheres. I like it. I like to keep it simple. Control C. Click the image to replace. We paste it, and there it is. All right. Let's talk about the viewing range. So we're going to be messing with the range menu, which is up at the top. You can see it there. So the range menu is accessed with the range button, or by going to transform, atom range, and then set range, or just press Control R. And so I'll go through that, navigating using the toolbar. Like in case the range button doesn't work for you or something, you can go to transform, and then atom range, and then set range. And so that should just pop up this menu. Okay? And so what do we want to do with that? We want to expand the crystal first. Let's jump back into ball and stick model real fast to demonstrate what's being talked about. So notice that like we have this oxygen here. It's just floating off into nothing. And we have like these incomplete bonds for the aluminums, our pinks. Remember, they're supposed to have 6, but I can rotate this around and I can see it only has 4. That's not right. But notice all these problems are on the edge of our crystal. And so the reason that there are things like hanging off out to the edge or not connected is because they would be connected if we zoomed out, if we extended the range of our crystal. And so that's what we're going to do. So our next task is in the range menu, click expand range 10 times, which every time you click the expand range button, it increases the range that you're viewing by 10% in all spatial directions. So 10% in X, 10% in Y, 10% in Z. And you just boom, boom, boom. We're going to do that 10 times. And what that means, if each click is 10% and we're clicking 10 times, that means that we're going to expand 100%. Okay? So let's do it. We're going to go to range, and we're going to go to expand range, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now we've expanded our crystal 100%, excuse me, 10 times, 100%. And so now we've got just, it's the exact same chemical structure. Nothing has changed chemically. It's just there's way more atoms now. 100% more atoms, some might say. Okay, so we just want to take a picture of our crystal expanded 100%. So I'm going to center and scale. We'll get like a nice sort of side-on view here so we can see how big and boxy it is. We're going to copy our graphics. We're going to click the image. We're going to replace it. Perfect. All right, so let's talk about the unit cell in more detail. So in the set range menu, we're going to click the cell contents button. So that's in this range menu, the one we just opened. In the bottom right, you see it says cell contents. So we're going to click it. Okay. Now we have much less information. We have gone down to just that little box. So if you noticed before how small the box was in our 100% model, now we've just got everything scaled down to just what is inside this box. Remember, you can turn this off and on with the cell button, just for some fun. Okay, so we lost a bunch of information there, but we are going to talk about in detail what the unit cell means. And so I would recommend reading this little paragraph. I'm not going to read it to you here because that's boring, but read it. It's helpful. And so what we're viewing now is a single unit cell of forsterite, in your case, kyanite in mine. So if I went to any mineralogist and I talk to them about a unit cell of kyanite, they would know exactly what I mean. They would know that it's a bunch of atoms. It is specifically this many oxygens, this many aluminums, this many silicons. Okay? So the unit cell is very convenient. It lets everybody get on the same page. We all know what we're talking about when we talk about the unit cell. It's this many atoms of this particular crystal. Yours will have likely a different amount of oxygens and silicons, and then you'll have magnesium instead of aluminum. But if somebody talks to you about a unit cell of forsterite, you'll know exactly what they mean now. And so if you haven't already, switch your model to ball and stick. I've already done that. And so we're just going to document our single unit cell. So we have our unit cell. I'm going to Control C. I've copied my graphics. Replace. And there it is. Okay. Next task. We want to count the number of silicon, oxygen, and magnesium. For you, it's magnesium. For me, it's aluminum. We want to count the number of those atoms in the unit cell and document the number of each one that you count. So you have a table down here that you're going to fill out. And for you, it'll be how many magnesiums are displayed in the unit cell in the second column, how many silicons, and how many oxygens, right? For me, just to sort of keep things straight, mine is aluminum. All right. So you can do that sort of, with everything displayed manually. You can just sort of like, move this around and make sure you remember which is where. But I think it's easier if you turn off the things that you're not counting. So the first row on that table was aluminum. So let's turn off everything except for aluminum. And you do that by ticking these boxes under the visible tab, or the Viz tab, the atoms inspector. So we tick those boxes. And away go the oxygens and the silicons. So now it's very easy to see that what I have is 8 aluminums. So I'm going to go in here. There are 8 aluminums displayed in the unit cell. Okay. Next up is silicon. So we're going to turn the silicons back on. Very easy to see now. There are 4 silicons. 4. Now we count the oxygens. Turn off silicon. Turn on oxygen. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 oxygens. 20. And notice each of these is divisible by 4. There's a common denominator of 4. So if we divide 8 by 4, we get 2. If we divide 4 by 4, we get 1. And if we divide 20 by 4, we get 5. All right. Now, why did we do that? Because we can use those numbers to determine the mineral formula of, in your case, forsterite, in my case, kyanite. So, what is our mineral formula? So, if you know anything about mineral formulas, like, for example, silicon, or quartz, rather. If you know quartz, its mineral formula is SiO2, right? So that means it has 1 silicon, 2 oxygens. That describes quartz. For ours, we can see we have 2 aluminums. So I would bet money that it's Al2, not 32, and not 3, but 2, Al2. We have 1 oxygen, 1 silicon. So Si, don't have to put a number after it. And then we have an oxygen. How many of them? 5. So if I've guessed correctly, or if I've thought about this correctly, I didn't guess. I have a reason for believing this. If we've done this correctly, the mineral formula for, in my case, kyanite is Al2SiO5. So let's go find out. In the Info Inspector tab, we can see the mineral formula, the chemical formula right there. It's either at the top or right here. Chemical formula, Al2SiO5. Awesome. So let's just talk through that again briefly. This is our unit cell. This is a unit cell of kyanite. It has 8 aluminum. It has 20 oxygens. It has 4 silicons. But you can reduce all those down to their lowest common denominator. And that gives you the mineral formula. So what the unit cell contains is not the mineral formula exactly. Right? We had to divide it by 4. We had to divide up all the numbers in the unit cell by 4. What it contains is the atoms that make up the crystal in the correct proportions. And dividing those proportions down to the lowest common denominator gives you the mineral formula. So that is why unit cells are important. They describe, this is the smallest amount of information that describes a kyanite crystal. Any smaller, we wouldn't be describing kyanite. If we were missing 2 of those oxygens, that would no longer be kyanite. Right, so this is the smallest amount that we can have and still call something kyanite. Great, so we have done our whole assignment. So please fill out this feedback. It helps us a lot. I hope this video was helpful, and I will see you in the next one.